Hello. Thank you very much, Sang-Ho. Um, so I think there's been some excellent talks here today. Really glad that the Facebook one got out of the way, so everyone that's left here is all very serious about explainable and understanding AI, which is great for me. Do I get to click that? There we go. So, Sang-Ho gave a great introduction. Fundamentally, one of the things we work on is understanding how these AI systems work. So, a lot of the talks today talk about implications of this, specifically around bias. So, what are some of the other negative aspects that happen, and how do we deal with these things? How do we actually understand them? How do we remove them from our models? And how do we build systems that are not going to be affected by these scenarios? There we go. So I don't think I need to tell everyone that AI is getting a lot of hype right now. It's out there. It's looking at affecting every industry. So one of the things we talk about is that AI, there we go. The way it is today, AI has been, specifically deep learning, has been seen to be a universal function approximator. What that means is for any arbitrary input, we can map it to an output. And that is incredibly powerful for what it does. So no matter what inputs we give, it will be able to learn the mappings that we give it. Now, the problem with that is, has it learned the mappings in the right way? Today, when we give deep learning models, they're classically seen as a black box solution. This means we don't fully understand how these systems work. So why does it make a particular decision? When is the model going to fail? How can it be fooled, which is incredibly important? These are things that are not known to developers of AI models today. And it's something that I and the IMDA think is incredibly important. And one of the things we talk about a lot is, how will these systems generalize in the real world? So we build models to reduce an error on a test data. But what does that mean when I actually bring that out into the real world? If I've got an autonomous vehicle AI that is going to drive an autonomous vehicle, on this test data, maybe it's going to get 92%, but when I bring it into the real world, how is that actually going to perform? So that brings up a lot of ethical issues for companies that are out there. So autonomous vehicles obviously is one that's got a lot of press. So Uber had an incident and they had to shut down their autonomous vehicle program for almost a year. Tesla, I think, has had 3 fatalities right now, which is obviously a huge, huge negative impact of the systems that they've built. So then the question becomes, why did this happen? Why did Tesla allow a system out there that was going to cause fatalities? And fundamentally, it comes down to, they didn't know. They didn't understand what the limitations of their models were. And then that's what exposed them to lawsuits, which they're going through right now. And then really what we see happening is regulatory compliance, insurance compliance. So how is an insurance company going to insure you against risk if it doesn't understand what the risks associated with your model is, right? And that builds into what we call AI auditing. So today you do financial auditing, cybersecurity auditing, but neither of those are actually going to kill you, whereas an AI can drive you off a cliff, it can give you the wrong medication, et cetera, et cetera. So being able to understand these systems is hugely, hugely important to us. So just to give you, to highlight some of the negative effects that can happen, I'm going to look at some computer vision tasks. So mainly focusing on images, because this is what our monkey brains find easiest to understand. But there's ways that these systems can go wrong that are non-intuitive to us by making spurious correlations. Bias is something that's been talked about a lot today. Adversarial attacks, which I love, I find really interesting. And then the lack of generalizability that we talked about. So in this first example, some researchers took a data set of wolves and huskies, and they train a model to predict, is it a wolf or is it a husky? And when they trained their model, it got 92% accuracy. So by all standards, it's a good model. It understands what the difference between a wolf and a husky is. But when they came back and actually used an explanation technique to understand why it made this prediction, you get this image on the right, which is looking at the snow around the husky, or the wolf in this case, sorry. So really what they'd actually built was a snow detector, because all of the wolves in their training data were standing in snow. So if you had a giraffe standing in snow, it'd call it a wolf. If you had a giraffe standing in grass, it'd call it a husky. So this is obviously not the behavior that we as humans want, but mathematically, that was the correct behavior that the algorithm learned. This is a video from a company that we work with, who are a face detection company. And obviously there's 3 people in the video here, but only 2 are being recognized. So what is happening that the person in the middle isn't being detected? So there's some inherent bias within this model that isn't picking up that there's a third person in this video. And I know all 3 of these guys, they developed the algorithm, so there's no excuses for any of them, right? Adversarial attacks, which I love. On the left-hand side, we give an image to a model, it calls it a panda. In the middle, we've got some random noise, and if we give that to a model, it's not at all very confident, but it says it's a nematode, but with very low confidence. If we then add those 2 images together, we get the image on the right-hand side, which to us as humans, the difference is imperceptible. We can't see the difference between the image on the very left and the image on the very right. But to the model, it now thinks with 99% accuracy that it sees a gibbon. So why is this happening? All right, if you look on the bottom right, my friend here, Chris, the guitar-playing monkey, is being labeled as a person holding a bird. Obviously, neither of those things are actually true. And just quickly to illustrate, we have a video here of a model working in real time. It sees a banana. If we put in a picture of a toaster, it sees a little bit of a toaster. But if we put in this weird image here, it now bombs out and maxes out saying that all it sees is a toaster. Now, what if I can put a sticker on a stop sign so that an autonomous vehicle doesn't see it? Or on the back of my vehicle so it doesn't think that I'm another vehicle, that I'm a pedestrian, let's say. What are the knock-on effects of that? So that brings me back to the point of why do we want to interpret these things? Why do we want to understand? Well, the first thing is to understand why they're working. Are they working in the right way? Are they being right for the right reasons? So if an autonomous vehicle crashes, why did that happen? What didn't it understand so that we can make it better over time? And obviously this has huge implications in the medical field as well. And today the way things are trained is you collect a lot of data, you build a model, you try and minimize some test data error, and then that goes out there into the real world. But really what we would like to have is when we build a model off of some data, we would like to validate that. We would like to understand what has it learned, why is it making these predictions, so that we can ensure that they don't make incorrect decisions. And there's obviously the old classic where we want to learn from machines. So machines are incredibly good at picking up structures and data that us humans cannot do. A perfect example of this was when AlphaGo played against Lee Sedol. There was move, I think it was 37 or 47, that was made where all the Go experts said this was not a move a human would make. They thought it was a mistake. But when they looked back at the game later, that was the turning point in that game, that move 37, which they said no human would make. So they were able to extract information, new ways of playing the game that weren't understood before by understanding the data. So just to recap, where we are today is we give a model a lot of data, and it gives a prediction probability, says this is a cat. But it doesn't tell us anything about why it does that. So we have no idea when it's going to fail, how it will be fooled. And really where we'd like to move to is it telling us it sees a cat, but telling us why it says a cat, because it sees whiskers, fur, claws, etc., etc. We wanted to tell us when it's going to get confused. What in the image doesn't it understand? So then to take this into the real world, I'm talking a lot about high-level concepts. and bringing it back down to some real-world use cases. The co-founder of my company, Naresh, came from Procter & Gamble, where he built a system to read in sensor data from a manufacturing line and then predicts when events would happen. So classic use of machine learning, feed it in some data with labels, and then you can predict what happens. The system he built got incredibly accurate. They gave him a big award. Everyone was happy. But they realized pretty quickly that if you tell an engineer that this robotic arm is going to break down in 30 minutes, what can they do about that? If I came out to you and said your phone is going to break down in 30 minutes, what are you going to do? How are you going to fix it, right? You don't have enough information to understand. So just predicting a task isn't always enough. So they came back to Naresh and asked him, why is this thing going to happen so we can prevent it from happening? So he built the first iteration of what we're calling interpreters for the deep learning model to explain its predictions. So now it tells an engineer, this robotic arm is going to break down, but it's because this timing belt is moving too fast, or this heat sensor is too high, whatever it is. Fix these two things and your line stays up. And when they actually implemented that, it had a huge, huge impact on uptime of the line. They were able to resolve a lot of issues because they understood why these things were happening. And then in the case of medical imaging is a huge, huge use case for AI right now. So there's a lot of companies out there saying we'll predict breast cancer, colon cancer, whatever it is. But when one of the largest companies in the world came out with a product to predict cancer, they had huge issues in the real world. When they gave it to doctors, if it agreed with doctors, doctors said, great, it works. But when it disagreed with doctors, they went with their own experience because they had no understanding about why the model was saying this is cancer or this is not cancer. So it ended up adding essentially zero value to the doctors that were out there. So in the computer vision use case, really what we want to see is why is the model saying this? What are the relevant features within this image? So here we've got a GIF of a model where we give it a pepper, and we want to understand why is it saying pepper. So we show what are the most relevant pixels, what are the most relevant features within this image to why I've said pepper. And in this case, it's the lumps and bumps and the structure of the pepper. But we also want to understand why didn't it say apple, right? We understand not just why it's predicting one thing, why isn't it predicting something else? So in this case, we're looking at a shark and a scuba diver, and we want to look at the differences between those. So this is really, really important, valuable information. And past that, we want to understand when is the model confident? So in the case of the gibbon earlier on, it was 99% confident as the output of a model. But that obviously isn't correct to what we understand. So we want to know if the model is getting confused from what it has learned, is it able to understand what it is seeing? And intuitively, I think most people will understand that if you're trying to teach a model to make it better, if you're teaching it with examples it already understands very well, you're not going to teach it anything new. So you want to select information that is in some way confusing, that it doesn't understand very well, so you can teach it new things and make it better over time. And the kind of last feature I'll talk about is that within a neural network, they're incredibly good at figuring out patterns. So if I have a face detector and I give it an image, it'll tell me if there's a face in there or not. But what does a face detector need to understand to know there's a face? It needs to know there's eyes, nose, ears, mouth, etc. These are all things that the network understands on the inside, but today there's no good way of getting that out. And we call it sub-pattern extraction. So it's some feature of the output class that you're trying to predict. And being able to understand that information is hugely valuable to us as humans. So if it's saying it sees a face, where does it see eyes, nose, ears, mouth? If it's making an incorrect prediction, we can ask it, where does it see eyes? Where does it see nose? Where does it see mouth? So in this example here, there's a huge amount of sub-patterns that we train networks on today, but we never interrogate them to understand them better. So in this image, there's different fabrics, patterns, there's female hairstyles, length of the dress, etc., etc. These are all things that we can actually interrogate systems to figure out Are they working in the way we want? And then this comes back to any physicists here will know Richard Feynman. He tells a great story about how difficult it is to answer a why question. So if your aunt went out and slipped on the ice, why did that happen? Why was she taken to the hospital after? It's because her husband loves her and wants her to be okay, so he took her to the hospital. Why did he take her to the hospital? Why did she slip on the ice? And then you end up in these cases of the little kid asking, why? Similarly with AI systems, we need to understand what the whys are. What do we actually want to understand from these systems? What's the valuable information we need to extract so that we as organizations can get the understanding that we need? So I would ask you all to think about your individual companies, your organizations that you're working in. If there was an expert in your field, what would it take for you to believe an expert? Is it because they've got lots of experience? Is it because they've got qualifications? Is it because they can show examples of what they've learned? Whatever those criteria are, why shouldn't we be asking AI systems in the same way? And quickly, just to wrap up, I would like to say that the EU just brought out a new report 2 days ago, which is giving some really cutting recommendations, saying that they should ban all AI enabling mass-scale scoring of individuals. So this touches on some of the points that people have brought up earlier. And this is only 3 months after they brought out a report on ethical guidelines for trustworthy AI. So the EU is really serious about AI governance, and I think that every company here should be as well. So then it comes, how do you start? Where do you begin? How do you get involved in this stuff? And I would like to thank the IMDA for inviting me here, but also their AI framework, which I think is an excellent document, which really aligns with what we as a company and an organization talk about, the philosophy that we have. There's some excellent quotes in there around the need for something to be explainable, transparent, and fair. And any organization looking to implement these systems really should be reading this document, and I think it builds a great framework for you as an organization to implement these systems. So just closing off, the take-home message is that AI systems are here. They're already here. They're incredibly powerful. But there are huge challenges for us as a community, as a field of research to overcome. And for you as organizations, having frameworks and standards to understand these is hugely important. And one of the things that I think most people don't recognize is that it's a continuous process. We don't implement a system, then release it to the world, and that's the end of it. It is an ongoing process that organizations need to commit to. So I would recommend start planning today, and then, as I think other people have mentioned, there's lots of people out there to help you, right? So we as an organization, the IMDA, have been excellent. Their framework is excellent. I would say be open and honest about what you're trying to achieve, and there will be help out there to achieve your goals. So I think I'm over time. I'll cut it there.
Any question from the floor? Okay, just one question over there.
Hi. So my question is basically about auditability, especially in terms of getting sustainability of AI outside of the company, because it's nice that you can explain what happened to your AI and in some kind of emergency, but then the senior execs basically bury all that. So how basically, what are the emerging standards in order to get accountability out, like something like a financial statement where everyone basically sees how the performance of the company essentially?
Excellent question. So that is specifically one of the things that we work on. So being able for an external agency to come in and understand what is happening within this AI model, let's say it's an autonomous vehicle or a medical AI, whatever it happens to be, understanding why it's making decisions, what are the limits of its understanding, when will it be fooled, adversarial attacks. These are hugely important things, A, to regulators, B, to insurance agencies, but to us as human people, right? I think everyone understands that when it relates to them, they're very personal about things. So why did it make a decision about me? Why didn't it give me a bank loan, etc.? But when we talk in broad generalities, people are less willing to commit to those standards. So that is one of the things that we do, which is trying to be able to integrate with other companies' models and make those explanations. So I would claim that we're state of the art. You can argue against that if you want. But there are ways of doing this. So a model is trained on some data, so it has learned some features. So no matter what your model is, no matter what the task is, there is a model that has been trained on some data. So we should be able to figure out these things. What has it learned? Why has it learned these things? What are the limits of its understanding? And fundamentally, I think that's the way the industry will go. And I think it's important for us as humans to do that.
Okay. Just one more question.
Sorry. Hi. A question. Thank you first for the very interesting speech, and I think those topics are crucial for AI. As a researcher with several experience on AI, I know that every model is an approximation of reality, and depending on the data that we have, the approximation may be better or worse, right? And even giving an explanation on the models, I have an impression that we will never reach the stage where the models are absolutely right, because we take data from humans, and humans are sometimes irrational, emotional, and we sometimes make wrong decisions as well. So I just wanted to give a comment and also ask, like, do you think that even giving explainable AI, can we reach the stage where we can trust entirely AI? And like, for instance, with the self-driving cars, there is like big hype because Uber, or it was Tesla, I think, there were 3 cases of mortality. But how many drunk drivers do we have, for instance, right? How inaccurate and imperfect are we? And should we believe that one day we'll have 100% of accuracy, or should we compare on what we have now in society? Because given even that example, I think that maybe one day we should only have autonomous cars driving, and it will be paper cars, right? Not to kill anyone, I don't know. So maybe we should exclude entirely drivers as humans. So what are your thoughts on that?
I think it's an excellent question, and I agree with you. If we were today to get rid of all human drivers and just have autonomous drivers, we would, on the average, we would reduce deaths. So it depends what your goal is. As a company or as a country, what are you trying to do? Are you trying to limit freedoms? Are you trying to reduce deaths? I think there's different variables here that are outside of the technical aspect. On the ethical side of things, I agree. If we were to ban human drivers today, we would have less deaths. But that doesn't seem to be the way that we as humans want to interact with these systems, right? So it's on us ultimately. And then the first question you asked, if I'm remembering correctly, is around, is explainability enough? So we see explainability as this broad topic. So it's not just why did you make a particular decision, but it's about understanding why they made the decision with respect to other aspects. So one of the things we talked about was sub-patterns. Does it see a nose, eyes, ears, mouth? Looking at an image and looking at the important pixels isn't enough of an explanation for humans. But if you're dealing with another human, if you're dealing with a medical doctor, what is it you would trust from them? If he points out, here's a lung nodule that I've seen before that I think is breast cancer, is that enough for you as a person? Then we should be striving to at least have AI systems giving that level of explanation or more, right? So giving examples, here's relevant samples from the past that turned out to be breast cancer based off of this type of pattern. So I really do think we can get there. I wouldn't be doing this otherwise. But yeah, the bar has to be raised. And we see that across the board in AI systems, that the bar we set on these systems is higher than we do for humans, which I agree, we should. Why shouldn't we strive for better? But there's still a lot of work to do, I think.